For the energy meter, we have already completed various portions, that is the construction, working, and various errors of energy meter. Now we will be seeing the meter connection of energy meter. How we will be connecting the energy meter in our home or as well as our industry. As we know, there are two connections. That is the very two important part. First one is the voltage part, and second one is the current part. So this voltage coil needs to be connected in series. Sorry, the current coil needs to be connected in series, and the voltage element needs to be connected in parallel. That's why, see, we are having a single phase connection, or we are looking the meter connection for a single phase meter. So this is our single phase connection will be coming to our home. From that, one line we have to connect with the directly to the load, and the other will also be connected to the load neutral. Okay, the load line will be connecting directly to the load, and the neutral line will be connected to the neutral. And in between two, that in the parallel connection, there will be two phase. That is the voltage element need to connect it in the parallel. Okay, it's a very simple connection. We will be having four terminals. According to four terminals, we have to connect the energy meter. Clear? So there will be two lines. This voltage line will be connected in the meter internally. So we just need to connect the single phase line and the load line accordingly. Clear? It's a very simple connection. Now, the very important another part is electronic energy meter. Till now, what we have already studied, that was a analog energy meter, means that was the induction type rotating energy meter. Now we will have to face the electronic energy meter. Nowadays, in our home as well as industry, for the error-free operation, need to mention for the error-free operation, and already we have seen various kind of errors in the energy meter. For the error-free operation, we need to go for the electronic energy meter. Now, how it works? The energy meter mainly works on a DMT, that is the digital micro technology. Try to understand the full form. DMT, digital micro technology. Already you guys have studied that analog electronics and digital electronics and applied electronics also. So this is a part of that electronic part. Okay. The functions are controlled by the specifically designed IC known as application specified integrated circuit. Okay. It is a very important part. It's a very common name rather, application oriented IC. That's why the name is application specified integrated circuit. The analog circuits are also present in the electronic energy meter to sample current and voltage. But we need to convert that analog data into digital data so that we will be using the electronic meter. The input data, that is the voltage, is compared with the program preference data, and the voltage rate is given to the output. Is given to the output. The output then converted into digital data. That is the very important part you have to understand. First of all, there will be the simple voltage connection. That is it is the analog connection. That analog part need to convert in the digital part. So the average value or the mean value is measured. That is the unit of power. The output of ASIC, that is the application specified integrated IC, indicated by the LED. Okay, we might have seen on our home, mostly in our home, that is the digital multimeter or the digital energy meter or the electronic energy meter is connected. There we would have seen that there is a LED bulb which is to at a specific time range. If the load increases, the blink will increase. If the load decreases, it will slowly blink. Okay, similarly to the this type energy meter. These pulses are equal to the average kilowatt hour per unit. Okay, for the analog electronic meter, there was a speed revolutions per kilowatt hour. There was a, in the analog electronic meter, there was a revolutions per kilowatt hour. Here it will be blink per kilowatt hour. Okay, that is a LED part. Now, the various components are registers will be there, electronic counters, universal counters, comparators, gauge generators, LED, LCD, logic circuits, and analog to digital and digital to analog converters. These are the various important parameters of the electronic energy meter. Here, these are required for various functions. That is, suppose that first of all we need to have a logic circuit to compare the voltage and the current. Then also we have analog to digital and digital to analog converters, means we are taking the analog input, that is the voltage and current. We need to convert that into a digital part. So that we need a digital to analog converter, and again the digital data need to convert in the analog, showing that that's why you need a digital to analog part. Okay, first of all analog to digital to convert the real time voltage into current to the comparator using a comparator. Okay, we'll be having input voltage, input current. We'll be using comparator so that we can convert that analog into digital, and again the digital data need to convert to the analog so that we can get a specific value or the LED output. Now this is a very basic diagram of an electronic or the smart energy meter. Clear? It's a very simple. That is a, we are having an energy meter. First of all, there is a relay connection. You would have studied in the power system. That is a relay connection which is directly connected to the load, and that energy meter through the optocoupler. We are using the 8085 microcontroller, and a specific controlling program is dumped here by the using EPROM and the power supply. It will do the calculation and everything, and finally we will get the data at the LCD. Here in place of blink. These are the very simple block diagram of our electronic energy meter. Now, so this electronic energy meter has a various advantages. First of all, the display is LCD or LED monitor. That is a very important part. Second, it will calculate the real power, reactive power, and the apparent power. Clear? It will calculate the real power, reactive power, and the apparent power. Whereas for the case of analog electronic meter, we are having a simple real power. There's a calculate bill in specified tariff plan. Also, you can easily reset the value and send blinking information to remote wirelessly also. We are very much, this is a smart connections are there. Nowadays, we can monitor the wireless connections using wireless connection. That is a remote monitor. Remote monitoring we can do using this electronic energy meter. And some has prepaid features also, means we can give previously based, means the amount we are going to use in our next month, we can use the prepaid bill also. Okay, these are the various features of electronic energy meter. So it is a very important study to try to understand. This will have a 5 marks question. That's the electronic energy meter, and a short note will come. That's why you have to know the how working. First of all, the working, then the register, electronic counters, universal counters, generators, gate generators, LED, LCD, logic circuits, and especially the converters. You will have the MCQ on converters, that is analog to digital or digital to analog converters. Then that is a important is a simple block diagram. You need to remember and write it has a various features, the advantages of electronic energy meter. The main advantage is we have the remote monitoring as well as the exactly data, that is the LCD or LED monitored data. And just have a small recap, that is the another important part of this module. That is the various errors. Okay, phase error, speed error, frictional error, and most importantly, clipping error, repeatedly I am mentioning, and temperature error. Frequency and voltage variation, these are negligible errors. Okay. So do the, this is the almost completion of this energy meter part. Study in home. If you have any doubt, just inform me and do a conference call or the simple call if you are having any doubt.